All right, everybody. Hello, hello. Welcome back, everyone. How you doing today? My name is Michael. Hope you're having a wonderful Saturday so far. Today is Saturday, January 25th, 2025, and we're back learning some Harvard CS50X, learning about some C. Gonna try the problem set 3 runoff and Tideman problems, hopefully, if we can finish them today. That's the goal. But they are pretty challenging, so we might not be able to finish them in their entirety today, but that's okay. How you guys doing today? Welcome in. Let me go ahead and make sure. All right, let's get started here. All right, runoff. You already know about the plurality elections, which follow a very simple algorithm for determining the winner of an election. Every voter gets one vote, and the candidate with the most votes wins. But the plurality vote does have some disadvantages. What happens, for instance, in an election with 3 candidates and the ballots below are cast? Alice, Alice, Bob, Bob, Charlie. A plurality vote would declare a tie between Alice and Bob since each has 2 votes. But is that the right outcome? There's another kind of voting system known as a ranked choice voting system. In a ranked choice system, voters can vote for more than one candidate instead of just voting for their top choice. They can rank the candidates in order of preference. The resulting ballot might therefore look like the below. Okay. Here, each voter, in addition to specifying their first preference candidate, has also indicated their second and third choices. And now that was previously a tied election could now have a winner. The race was originally tied between Alice and Bob, so Charlie was out of the running. But the voter who chose Charlie preferred Alice over Bob, so Alice could here be declared the winner. Ranked choice voting can also solve yet another potential drawback of plurality voting. Take a look at the following ballots, right? Who should win this election? You have 2 for Alice, 3 for Bob, 4 for Charlie. So in theory, you have Charlie wins this election. In a plurality vote where each voter chooses their first preference only, Charlie wins this election with 4 votes compared to only 3 for Bob and 2 for Alice. But a majority of the voters, 5 out of 9, would be happier with either Alice or Bob instead of Charlie. By considering ranked preferences, a voting system may be able to choose a winner that better reflects the preferences of the voters. One such ranked choice voting system is the instant runoff system. In instant runoff election, voters can rank as many candidates as they wish. If any candidate has a majority, more than 50% of the first preference votes, that candidate is declared the winner of the election. If no candidate has 50% of the votes, then an instant runoff occurs. The candidate who received the fewest number of votes is eliminated from the election, and anyone who originally chose the candidate as their first preference now has their second preference considered. Why do it this way? Effectively, this simulates what would happen if the least popular candidate had not been in the election to begin with. The process repeats. If no candidate has a majority of the votes, the last candidate is eliminated, and anyone who voted for them will instead vote for their next preference, who hasn't themselves already been eliminated. Once a candidate has a majority, that candidate is declared the winner. Sounds a bit more complicated than the plurality vote, doesn't it? But it arguably has the benefit of being an election system where the winner of the election more accurately represents the preferences of the votes. In a file called runoff.c and a folder called runoff, create a program to simulate a runoff election. Distribution code, here we go. So let's go into here, copy this guy. Hey Garrett, how's it going? Hey Tim, welcome in. How you guys doing? Awesome to hear from you guys. Let's unzip it. Let's remove the zip. Okay. Let's CD into runoff. And now we're in. Okay. Understand the code in runoff. Okay, so we have some um, define variable here. For max voters is 100, constant. Max candidates is 9. You can have 9 candidates and 100 voters maximum. Int preferences. Preferences index I and j is the jth preference of voter I. So you create a matrix here where you have the max voters times the max candidates. Then you have a construct for actual candidate with the name, the number of votes, and a boolean for eliminated, which can be true or false, okay? And then you have an array of candidates, number of voters and candidates, int voter count, int candidate count. Function prototypes. We have a vote function, a tabulate function, a print winner function, a find minimum function, a bool is tie function, and an eliminate function. So int main, int argc, string argv. We need more than 2 arguments. The candidate count is equal to the arg count minus 1. If the candidate count is greater than the max candidates, return an error. Okay. We iterate over the candidate count. We access every candidate's name. Save it as the next argv value. And set their elimination to false and their votes to 0. Hey, Natty Sanis, how's it going? Welcome in. How you doing today? Welcome back. Okay, so then what would we do? We get integer from the user, number of voters. If it's greater than the max voters, we say that we return 3, saying it's greater than max voters. And then we keep clearing for voters. We get number of voters. And then for the vote count, invalid vote. Okay. Keep holding runoffs until winner exists. While true, call tabulate. Calculate votes remaining until candidates. Okay, so we have a tabulate function here. Oh boy. So our goal here whenever you'll extend the functionality of existing code, it's best to be sure to understand it first in its present state. Look at the top of runoff.c first. 2 constants are defined, max candidates for the maximum number of candidates in the election and max voters for the number of voters in the election. Decide an array of candidates. Candidates is an array of candidates. In runoff C, a candidate is a struct. Every candidate has a string field for name and int representing number of votes. Now you can better understand preferences. The 2-dimensional array, the array preferences index I will represent all the number of preferences or voters. Number I Yeah, sorry guys. Oh, already starting off tired here. The integer preference I index j will store the index of the candidate from candidate's arrays who's the jth preference over voter I. Oh boy. The program also has two global variables, voter count and candidate count. The first call here is a function called tabulate, which should look at all the voters' preferences and compute the current vote totals. Record preference if vote is valid. So bool returns a boolean for vote, given a voter, a rank, and a name. Record preference if the vote is valid. So vote is here. Oh boy. Oh boy, oh boy, oh boy. Some advice. Could complete the vote function. The function takes three arguments, voter, rank, and name. If name is a match for the name of the valid candidate, then you should update the global preferences array. This problem is the most realistic one so far. I fix/extend existing code more than I write new code. Interesting. Okay, so let's think here. So complete the vote function. The function takes three arguments, voter, rank, and name. If name is a match for the name of a valid candidate, then you should update the global preferences array to indicate that the voter has a candidate as their rank preference. If the preference is successfully recorded, the function should return true. The function should return false otherwise. Consider, for instance, when name is not the name of one of the candidates. Oh, God. Why am I so tired? It's Saturday. I've been like so tired all day. Okay, so let's first focus on bool vote. So the function takes three arguments, voter, rank, and name. If name is a match for the name of a valid candidate, then you should update the global preferences array to indicate that the voter has that candidate as their rank preference. What? So I'm just not understanding what is really being asked here. Turn off my blanket's too hot. Okay. Hey, Trash Ketchum. Hey, Wingong. How's it going? Welcome back, you guys. Okay, so we call vote on this here. and we print a new line. So keep querying for votes. For I equals 0 until for the voter count. Query for each rank. And for j equals 0 till j is less than the candidate count. Rank integer j plus 1. So you'll continually provide a rank for every candidate there is. So voter count is the number of people times by the number of candidates gives you the number of votes. Hey, Code Guy, I just want to ask what webcam you use when you live stream. Funny enough, I actually just use my MacBook Pro webcam, the one that's attached to the screen. So yeah, this is pretty basic and kind of lo-fi and stuff. So it just goes to show you that you don't really need something fancy to get the job done here. I've just been making by with what I've got. So yeah, thank you for coming in, Code Guy. Hey, Insomniac, how's it going? What are you guys working on today? What are you guys studying today? How you guys been doing on this Saturday? Okay, so the rank just provides a rank at that certain point in time. So we need to validate pretty much that this vote is valid. So if you return false saying that's invalid votes, we have to make sure that this vote is valid. So we first need to check that the candidate's name is even in there. Okay, so here we'll say for int I equals 0, and so the candidate count is, well, the candidate count is greater than I. We'll continue to increase I forward. Okay. Oh, you must have a second monitor then because webcam is off to the side. Yeah, I have I'll try to show you guys. I have just my monitor right here. There's just a kind of a curved 27-inch monitor, and then I have my laptop here just on like a little stand. I'm studying React with you. I think we should all learn to code. Awesome. That sounds really cool, Code Guy. What got you into learning React and what kind of stuff you making? Insomniac says I'm building an LLM from scratch. That's what I'm studying. Oh, cool, man. How far are you in that? Like, what kind of knowledge and what kind of sparked that interest, Insomniac? Okay, so we need to first verify that the name provided with this vote is a valid name. If the name is a match for the name of a valid candidate, then you should update the global preferences array to indicate that the voter has that candidate as their rank preference. So do we have a voter constructor? Voter count, candidates. We have a candidate structure. That's a big OE. What's OE mean? VOE. I just want to build a full app by end of the winter. Nice. I'm also interested to know how you are live streaming. Yeah, I'm just using OBS, honestly. It's really, really simple. I just have my bitrate at 20,000 and I found that that's been kind of okay. Okay, so we're validating this vote right here. So if we successfully we loop over the entire candidate count, we say if candidates at index I right, if stir comp candidate index I and name equals to 0, right? What do we want to do? If we found a match for a candidate name, we need to associate this candidate name, right? It says indicate that the voter has that candidate as their rank preference. The global preferences array. So this is the preferences array. So it's I by j is the jth preference for the ith voter. So we access the ith voter and access their jth rank and save it as that candidate. Okay, so preferences. We're going to access the preferences array at index value I no. No, we're going to access the preferences array. We need to update the global preferences array to indicate that the voter has that candidate Okay, so preferences of index voter, right? So if preferences is the max voters, so the voter comes first by the max candidate, would be their rank. Preferences voter rank is equal to name. So we're going to access the two-dimensional matrix for the voter at that rank and insert the name of the candidate for that voter rank. So think of like a matrix chart, like a two-dimensional chart. We're going to access the voter across the x-axis, go up to the rank across the y-axis, and paste in the name of that candidate right there at that point in the okay. And then what? Return true here, like so. What do you guys think for this one here? So our goal here is to keep in mind 0 is the first preference, 1 is the second preference. You may assume that no two candidates will have the same name. Keep in mind that 0 is the first preference, 1 is the second preference, and so on and so forth. So this would be candidates index I dot name. So if candidates index I's name and the name provided in the string is equal to 0, meaning that this vote was valid for a candidate, we take the voter and the rank the vote is given and assign that to that person's name. Now, what is this part about? Keep in mind 0 is the first preference, 1 is the second preference, etc. Just like the lower the value, the higher the rank. So we do this vote here, we get a name, and we rank that person. So we get an integer, number of votes, number of voters. We get a vote for each voter. So J, what is J in this case? J is the all the way through the candidate count. So 0 would be your primary rank. Okay. I think that this is okay then. What MacBook are you using? Yeah, I have a MacBook Pro 2023, 2024-ish version. It's the M3 Pro, not the base chip, but the upgraded chip on the M3 Pro version. Then I also have the upgraded RAM from 18 to 36 gigabytes. Okay. If the preference is successfully recorded, the function should return true. The function should return false otherwise. Consider, for instance, when name is not the name of one of the candidates. Okay, so then we should say false here, like so. So we're going to access that preferences voter and the rank of that voter and assign the name to that preferences voter and rank and return true from there. Else, if this does not equal 0, we're going to return false for that this candidate was not in the no, we don't want to return false here because that would return false on the first indication in the first iteration. So we want to return false just at the end, I guess, like so. if this is return true, the function should otherwise return false when the name is not one of the candidates. Okay, I think that is okay. What do you guys think about this for bool vote? For completing the vote function, what do you guys think about this? So our goal was to, the function takes three arguments: voter, rank, and name. If name is a match for the valid candidates, we iterate through all of our valid candidate count. We access the candidate at that index. We access the name of that candidate at the index. We compare that name to the name provided in the vote. If it equals to 0, which means that it is um, equal, then we access the preferences for that voter given in the parameter for that rank given in the parameter and set it equal to the name of that candidate and return true. What do you guys think about this function for bool vote? Anyone have any disagreements? Anybody have anything they want to add? Speak now or forever hold your peace. What do you guys think? Anyone have any disagreements? Now is the time to say something. All right. For those of you that are new, thanks so much for joining me here. My name is Michael. I just turned 26 a couple of days ago. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company where I make biological controls. I work as a chemist. I work in a very large lab, mixing various solutions and vats upwards of thousands of liters. I scale those down into smaller solutions, but I've been just teaching myself Python and how to code for the past half a year as just a way to further improve my skills as a candidate, as a scientist, and as just a in my education. So I really appreciate you guys joining me here. And if this is something that you find interesting or on like a similar learning path, independently learning, or just wanting to gain some more resources and exposure into this field, then feel free to join and follow along with me here. The channel has been growing quite rapidly over the course of the last few weeks, and so we've crossed over 1,000 subscribers a couple of days ago, and so thank you guys so much for that. I really appreciate all the support we've been getting. I'm setting preferences to something else. Let's see how it turns out. What are you setting your preferences to? What are you updating the preferences to? That's what so if the name is a match, then you should update the global preferences array to indicate that the voter has that candidate as their rank preference. So we access the preferences and the rank of that voter and set it equal to the name. That's how I have it. Well, what do you have it as, Ryan? That sounds so nice, Tim. Thank you so much. I appreciate those kind words. You're always so sweet. Yeah, I'm working hard. I'm trying to eventually, if we get there, if we can, try to become a software engineer in any sort of standpoint, whether it be a professional or just independent, then, that's fine by me. I'm just trying to, ride this wave and see where it takes us, this learning journey. It's fun and, yeah, is equal to I. Okay, you're setting it equal to I. You're setting it equal to I. You're setting it equal to I. So if you're setting it equal to I on this local scope, in my opinion, that's only going to equal just the order of the candidate, right? So the only thing I resembles here is just accessing the index values of each of the candidates. And so if you set it equal to I mean, yeah, it technically would work if you retrieved the index, retrieved that integer value, referenced it to index into candidates again, but by saving I as instead of name here, all you're doing is just saving the order, index order of which the candidates were just typed in by the user in their argv, right? Does that make sense, Ryan? Because that's all I is just the order that the candidates are in, whether when they were initially typed in their argv by the on initialization. What do you guys think about that? Yeah, Tim, definitely, for sure. I'm always open to open doors and stuff like that. Okay. As you write your code, consider these hints. Recall that candidate count stores the number of candidates in the election. Recall that you can use strcomp to compare two strings. Recall that preferences I and j stores the index of the candidate who is at the jth rank preference over the ith voter. Okay, so recall that preferences I over I to j stores the index of the candidate who is the jth ranked preference for the ith voter. So it does store an index of the candidate. So then if we do, based on this hint here, we would save I, like Ryan suggested here, and then you would just access the most reoccurring candidate vote. Okay, because I correlates to the index value in the candidate count, right, for the candidates. Interesting. Okay, I think that's fine. Let's move on to the tabulate function. Is rank only supposed to be the candidate's name or the whole candidate? Um, well, like it said that it was just a reference to the index value. Stores the index of the candidate who is at the jth rank. So in tabulate, the function should update the number of votes each candidate has at the stage of the runoff. The function should update the number of votes each candidate has at this stage in the runoff. Recall that at each stage in the runoff, every voter effectively votes for their top preferred candidate who has not already been eliminated. The function should update the number of votes each candidate has at this stage in the runoff. For non-eliminated candidates. Tabulate votes for non-eliminated candidates. So we just need to iterate over all of our current candidates and tabulate the votes Recall that at each stage in the runoff, every voter effectively votes for their top preferred candidate. Their second choice candidate is preference I, index 1, etc. Recall that the candidate structure has a field called eliminated, which will be true if the candidate has been eliminated from this election. Recall that the candidate structure has a field called votes, which you'll likely want to update for each voter's preferred candidate. So we need to update. Recall that once you've cast a vote for a voter, first non-eliminated candidate, you'll want to stop there, not continue down their ballot. You can break out of the loop early using break inside of a conditional. Whoa. Okay. The function should update the number of votes each candidate has at this stage in the runoff. So we need to say for int I equals 0, candidate count greater than I plus plus. So we tabulate, or we iterate over the candidate count. We access the candidate at each position I. If candidate at index candidates at index I dot eliminated right. So we need to detect if this candidate is eliminated or not before we can tally its vote. So right in the tabulate function, it calls tabulate here. Tabulate. Calculate votes given remaining candidates. Where does the candidate count change? Eliminate min. So if the candidate eliminated equals to false, right? If the elimination equals to false, we need to iterate over all of our preferences and find out so it's going to access the first candidate, access its eliminated field. If it's false, it's going to then go over all of the preferences and update the votes so if we're on a candidate for int j equals to if candidate count I at index I equals eliminated, candidates index I is eliminated. So we're accessing every candidate's. If their eliminated attribute is false, meaning that they're still active in the race, we need to currently go over our preferences and update the vote count The function should update the number of votes each candidate has at this stage in the runoff. Recall that at each stage in the runoff, every voter effectively votes for their top preferred candidate who has not already been eliminated. Voter count stores the number of voters in the election, and that for each voter in election we want to count one ballot. Recall that voter I their top choice candidate is represented by preferences I0. Their second choice candidate is preferences candidate. So I in this case resembles a candidate. So voter and rank. I is voter, J is rank. So we access all the candidate counts, access each candidate's eliminated. Oh my gosh, this is getting rough. If the candidate's index I is eliminated, it's false. Okay. This function should update the number of votes each candidate has at this stage in the runoff. For I equals 0, while the candidate count is greater than I, continually increase I by 1. Access if the candidate at index I eliminated attribute. Come on, stop yawning. Hiccuping. Is equal to false. What are we going to do if it's equal to false? Preferences is what? Preferences is max voters by max candidates. So the 0 candidate voter 1, voter 2, voter 3, voter 4. So what this looks like is this. You have voter 1, voter 2, voter 3. You have candidate 1, candidate 2, candidate 3. If voter 1 votes candidate 0, 2, 1, right? What about this 1, 0, 2, or 0, 1, 2? So that's what it would work, and then you would access candidates at this index value to see which one it is that they voted for in their primary position spot. Recall that at each stage in the runoff, every voter effectively votes for their top preferred candidate who has not already been eliminated. As you consider these hints, recall that voter count stores the number of voters in the election, and that for each voter in our election, we want to count one ballot. Okay, hold on. So let's go like this. For while I is equal, let's go to voter count, like so. We'll access, so we'll go through all the voters. We'll access the voter count. So the first voter. So preferences at index I. So we'll access the voter's preference at index 0 here. Hey Kai the editor, yo hi, where do you all get beginner projects to do? I would highly suggest taking a look at Python Crash Course. This book paired with Harvard CS50P was a great introduction to programming with Python. It has a couple of projects in the back of the book that you can use as templates to get started if you're having struggles, coming up with your own. But I have a copy of this PDF and additional notes and resources linked in my description below in my Discord. So join. Thanks so much for coming in, Kai the editor. Appreciate you coming in. So if preferences, if preferences I index 0, So what's going on? What is tabulate really asking us? Should we skip the tabulate and try to move on to a different function, the print winner? Complete the print winner function. If any candidate has more than half of the votes, their name should be printed and the function should return true. If nobody has won the election yet, the function should return false. As you write, because recall that voter count stores the number of voters in the election. Given how you would express the number of votes. Given that, how would you express the number of votes needed to win the election? The voter count divided by 2. Give us 50% of the voters. You need to be greater than 50% of the voters. Oh my gosh. So recall that voter count stores the number of voters in the election. Given that, how would you express the number of votes needed to win the election? Well, the number of votes needed has to be greater than the voter count divided by 2. So print winner, you have voter count. A print winner would be votes needed to win is equal to the voter count divided by 2. Why are you adding 1, John? Why are you adding 1 to your voter count divided by 2? Because you need one more count. You need one more vote. We'll say vote threshold is equal to this, right? We then say, so then what tells you if you have a winner, right? If the current vote count of every candidate so we have to say for I int I equals 0 through candidates so we're going to iterate over the candidate count if I dot elim candidate I eliminated is equal to false, and if candidate I dot votes is greater than votes threshold, printf such string index I name. We have a vote threshold. We iterate over the candidate count. We access every candidate at that candidate count. We access the eliminated attribute. If it's false, meaning the candidate is still active, okay, so John says if not candidate I dot eliminated, right? If candidates at index I dot votes is greater than the votes has threshold, will print candidate's name. Else return false. Okay. Yeah, that's a good question. Has anyone here finished the problem? John asks. Okay, so there's just a lot of steps. I wish there was a way to check that like each function before we move on to the next one is right. Like that's what I wish we could just check the specific function at each point. And the function should return true. But what if we have candidates with multiple winners here? You can print out the info you could expect to be counted here and see if it matches what you think it should be. So then, okay, what about in this find min? Complete the find min function. The function should return the minimum vote total for any candidate who's still in the election. As you write your code, consider this hint. You'll likely want to loop through the candidates to find one who is still both in the election and has the fewest number of votes. What information should you keep track of as you loop through the candidates? The lowest vote count. Okay. So find min we need to iterate over the candidates who are still in the election and have the fewest vote count. So for int I equals to 0, candidate count is greater than I plus plus, what are we going to do over the candidate count? We're going to access every candidate. So we'll need to have here put small or string or int equals or int smallest candidate votes is equal to, we'll just say that, right? We're going to iterate over. Equals to is equal to candidates dot index 0. Now smallest votes smallest votes, right? The thing is, though, if we're trying to find the smallest candidate, we save the number of votes for the first candidate. So you can't have more votes, right, than the vote count by the number of voters count by the number of candidates. You can only vote for one candidate per vote. So the number of voters times the number of candidates is the number of votes total. So just the number of candidates is just the number of votes per candidate. Right, so if the number of voters is 5, you have 5 voters and 5 candidates. You have a total of 25 votes, 5 per candidate. A total of 25 votes, but you can only vote for one candidate once. So that means that you'd have a total of 5 votes per candidate. So it'd be the number of candidates, right? The candidate count. We can initialize it as the candidate count is the largest possible number of votes you can have. But this whole thing with the rank voting is throwing me for a loop, right? Because you can have votes, but the only thing the rank does is if the candidate is eliminated, it chooses your next candidate. It's not like a magnitude thing, right? It's just if this candidate isn't available anymore, this is my next option. It's not like a magnitude difference. So if you have 5 voters and 3 candidates, you have a total of 15 votes. 5 per candidate, 3 candidates, 3 per candidate, 1 per candidate, 3 votes per ballot, 1 vote per candidate times 5 voters, number of voters. Yeah, so it's fine, really. So wait, if there's 3 candidates, 5 voters, you can have 5 possible votes for each candidate. So it would be the not the candidate count, but the voter count would be the maximum number of votes a candidate can have. So we're going to iterate over the candidate count if the candidates index I dot votes is less than smallest candidate votes. Oh, gosh. Return the minimum vote total for any candidate who is still in the election. If candidate votes is smaller than smallest vote candidate. So let's say you have 5 candidates. I have 5 candidates, or I have 5 voters and 3 candidates. So my 5 voters will have 5 different ballots, each of which will have a rank 1, 2, 3 on it. Meaning that you can put Y, 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 Y once across it 5 times. So the number of voters so at this point, so the number of 5 is the max number it can have. So if the candidate's votes are smaller than the smallest candidate votes, then and not candidates index I dot eliminated right. So if and the candidate is in play, then so we'll actually hold on, let's say index smallest candidate votes equals to 0 initially. So if the candidate votes right is less than the smallest candidate's vote is less than so we want to return what if you have int index is equal to 0? Okay. Oh, this one's hard. Jeez. So we are trying to find the minimum. So we're going to iterate over we're trying to find the minimum vote count on a candidate that is still in play. Are voted counted as the sum of the rankings from voters, or just one per person? Are voted counted as the sum of the rankings from voters, or just one? I'm not sure what you mean, John. Okay, so what's going on here? We need to return the index of the candidate that has the smallest number. To return the minimum total value who's still in the election. Vote total for any candidate who's still in the election. Just staring at this, feeling dumb. Anyone have any ideas? So, no, they cannot receive more than one vote from a voter. It's unique. Each voter gets one vote per candidate in a rank of their choice. Okay, so we need to smallest votes is equal to this. Int smallest votes is going to, what do we need to initialize it equal to? I'm stuck. Smallest votes is going to be equal to the voter count. If it's equal to the voter count, whatever, let's just try it. Okay, for int I equals to 0, while right? So yeah, voter count, because you only can get smaller from the voter count. So I equals 0. Candidate, find candidate count. We're going to access if candidate, if not candidate index I dot eliminated, right? And if candidate is not eliminated and candidate index I dot votes is less than smallest votes right? Smallest votes is equal to candidate index I dot votes. Return not 0 here, but smallest votes, right? What do you guys think about this? For find min, we set the smallest votes equal to the voter count because the maximum number of votes a candidate can have is proportional to the voter count. Each voter can have one count. Each candidate can have one vote per voter, right? But if that candidate is eliminated, obviously, then their vote won't count, and so they could have less. Okay. Now what about bool is tie? Complete the is tie function. The function takes an argument min, which will be the minimum number of votes that anyone in the election currently has. The function should return true if a candidate remaining in the election has the same number of votes, and should return false otherwise. Okay. So we say for int I equals 0, candidate count is greater than I plus plus, right? Is it raining? I think it might be. It might be raining out there. It's kind of loud. Okay, so we're going to iterate over again the candidate count for a range of the candidate count. Access each candidate. If not candidates index I dot eliminated. Ryan, where are you stuck at? I'm getting stuck here too, so don't feel I'm struggling here too, and I'm feeling I'm feeling it too, so don't feel bad. I'm right there with you. So is tie if the candidate is eliminated, not eliminated, right? And candidate index I dot votes is equal to min, right? Return the function should return true. Return true. Recall that a tie happens if every candidate still in the election has the same number of votes. Note, too, that the isTie function takes an argument min, which is the smallest number of votes any candidate currently has. How might you use min to determine if the election is a tie or conversely not a tie? Note, too, that the tie function takes an argument min, which is the smallest number of votes. The function takes an argument min, which will be the minimum number of votes anyone in the election currently has. The function should return true if every candidate remaining in the election has the same number of votes, and should return false otherwise. So every candidate is remaining. So then we'll say if candidate is remaining and equals min, do nothing. So if a candidate is remaining and the votes does not equal min, we're going to just return false here. And then we'll return true at the end here. So that'll cover it. Okay, that covers this function here. So we will return false if at any point through our iteration through our candidates, if their vote count does not equal the minimum, right? We do not have a tie. Okay, now let's look at the eliminate function. So min is the amount of votes at least one candidate has. Won't it be a tie if a candidate has more than min? But it's specified, though, that minimum will be if every candidate remaining in the election has the same number of votes. So I had to do every candidate evaluate. So if one candidate does not have a vote count equal to min, we return false on that candidate immediately. So now we have the eliminate function. Complete the eliminate function. Eliminate the candidate or candidate in last place. The function takes an argument min, which will be the minimum number of votes that anyone in the election currently has. The function should eliminate the candidate who has the minimum number of votes. Okay, so this one's pretty easy. So we'll say for I equals 0, candidate count greater than I plus plus, if candidates at index I is equal to the min, right? Not if the candidate dot votes is equal to the min, we're going to set the candidate index I dot eliminated equal to true, and just return off this. Eliminated equals to true. And we return back to the function. The function should eliminate the candidate or candidates who have the minimum number of votes. So this will put true for eliminated for every single one of the candidates and return after O of n loop. Got you. Okay, so then the only thing that we need here now, I guess, is the tabulate function. The function should update the number of votes each candidate has at this stage in the runoff. Recall that at each stage in the runoff, every voter effectively votes for their top preferred candidate who has not already been eliminated. Every voter effectively votes for their top preferred candidate who has not already been eliminated. So we need to go through the preferences. We need to go through the preferences. We need to evaluate at every condition of I and J, evaluate if at that index point, that integer at that cross section of I and J, candidate of that index dot eliminated is not true, is false, then we will go ahead and update that candidate's vote count to Hey Lath, how's it going? Welcome back. How's it going? What are you working on? Um Recall that voter count stores the number of voters in the election, and that for each voter in our election we want to count one ballot. Recall that voter I, their top choice representative is preferenced by that. So we'll say tabulate for I of the voter count. And then we'll say for int j equals 0, candidate count greater than j plus plus. Okay, we have two nested for loops now where we're tracking I over the voter count and j over the candidate count. Because the candidate count is basically the rank. So we go preferences at index value I and j. Right, this will access the index of that point. So we'll say candidates index value preferences I and j, which will give you the vote for that candidate. Dot eliminated if not candidates preferences I and j dot eliminated. Um, oh, I don't know. I don't know if I'm doing this right. Ugh, gosh. These instructions aren't that great. Tabulate votes. So we need to pretty much, we need to pretty much count the votes. Um, I don't know. Traveling around supporting hard down machines. Nice, man. Great that you were able to stop by here. Appreciate you, man. John, is the amount of possible ranks fixed or does it change depending on the inputs? What do you mean, possible ranks? So the only thing that the rank does is that it doesn't give you an order of magnitude of preference, right? It's not saying like, oh, my top choice gives me like one, my bottom choice gives me a half, and my third choice gives me a quarter. Whatever candidate has the total amount of whatever, then or the higher amount of value, then that's the candidate that has whatever. No, that's not how it works, dude. It's just if that's eliminated, it goes to your second option. I'm not sure here. So is there any other to-dos that we have to do, or is it just in these functions? So we call, not so great, Tim. We're stuck on this one. That tabulate function should work, you say? Right, so the preferences at I and J just tells you, right, all that preferences tells you, right, from here, the voter I and their rank, their jth preference, right? So if you go to this point at this matrix, it'll give you an integer value, right? An integer. Now, what does that integer tell you? That is the integer or index value of our given candidates. Right? That is the candidate that they're voting for per that rank. You're breaking out after adding a vote, though, you say. Recall that once you cast a vote on a voter's first non-eliminated candidate, you want to stop there, not continue down their ballot. So we want to break out of this for loop here, but continue on with the voter count for loop. Yeah, the rank is the index of that candidate. That's why this thing is getting all tricky. We want to update for each preferred voters. Hey, Override Tips, how you doing? Welcome in. Welcome. So I mean, we did the vote. We did the vote, the tabulate, the print winner, and the find min, and the tie, and eliminate. So is that it? How's the CS50 going? This one ramped it up quite rapidly here. It's gotten a little bit more difficult here. So I'm going to run a check 50, I think. Runoff compiles, code failed to compile even. So we have an error here somewhere. So hold on, let's see here. Let's go. Make runoff. We need the string H. Line. What line is that? 152. Yeah, spelling errors. 190. Eliminated. 204. Eliminated. I equals 0. We need int I equals 0. There we go. Let's check 50 here. We're getting clapped. Yeah, exactly, Tim. We're getting clapped right now. You guys are funny. Hey, Sam, how's it going? Welcome back. How you doing tonight? Okay, wow. That actually did a lot more greens than I thought we were gonna do. Wow. Okay. Okay. You guys, that actually did a lot better than I thought. I thought we were gonna fail everything. Okay, print winner prints names when someone has a majority. Print winner did not print winner of the election. Print winner returns true when someone has a majority. Winner did not. Wow, okay, we almost got this one. Let's go. Okay, I'm feeling a lot better now. I was thinking we were like really far away, but we are almost there. We're almost there. Wow. Right, John? I know, right? We're feeling good. Okay. So print winner, so our print winner function is what's wrong here. Print winner prints name when someone has a majority. Print winner did not print winner of the election. Celebratory wine class. I'm pouring one out for you. All right, Tim, let's go. That sounds great. I'll grab some lemonade here in a second for mine. Okay, so if the vote count is greater than the vote threshold, so let's say the voter count is 5 people votes. That means that you can only have 5 votes per. That means you have to have greater than 2.5 votes to win. So you have to have majority though. So you can't floor it. So if you have 4, you have to have greater than 2. If you have 5, you have to have greater than 2.5. Or 2. If you have 5, you have to have 3 people that win. So voter count would be 5 divided by floor 2. Floor division on 2 would be 2, and you'd be greater than 2. Returns true when someone has a majority. So we iterate over all the candidate counts. If the candidate we're currently on is not eliminated, and candidate votes is greater than the vote threshold, we'll go ahead and do this print. Yeah, 5 division 2 is going to return 2 in C. Yeah, it does floor division, right? Exactly. So 5 divided by 2 is going to give us 2 back. And so you need to be greater than 2. But in theory, you need to be greater than 2.5. You need to be 3 or more. I mean, by switching this up, so if I say voter threshold, so if I say 4 divided by maybe 2. No, because our ties happen here. We have a separate function for handling the ties. So 4 divided by 2 would give us 2, which means we have to have greater than 2 votes to win. 5 divided by 2 would give us 2, we need greater than 2, we need greater than 3 votes to win. So if we say plus 1 here, like so, right, if we say plus 1, then this would be winning votes is equal to this is greater than or equal to winning votes. So the candidate vote count has to be greater than or equal to the winning vote count. I think that'll do it. Yeah, we're doing runoff on week 3 right now, Ryan. No, still. Okay, so let's go back to our function here for, or our prompt here for print winner. If any candidate has more than half of the votes, their name should be printed on the function and the function should return and should print and the function should return true. Lose the greater than sign. Well, if I lose the greater than sign, would that really change anything? Right? Because it just has to be equal to, it could be greater than or equal to. Because they could have more than the majority. They could have more than. We don't want to be directly equal to the winning vote count. They could have more than the majority. Or the majority baseline, right? Majority is a set number. But you can have a candidate. Well, let's try it. Can you have a candidate that has more than I'm not sure. Yeah, this one. Yeah. See, a majority when someone has a majority. So that's why we have to do that. No worries, Cody Mountain Man. Yeah, I thought I'd reach out given your message the other day in the stream. For sure. Yours are all green. Then it just must be something else going on in my function here. Right, so this is going to give me the 2 wrong answers. Okay, so we have winning votes. Voter count. Hmm. Print winner returns true when someone print winner did not print winner and then return true. So we're not printing any winners here. Should I use the debugger? And put it here? Oh, it's just the \n. Is that really it? That might be, actually. Is that really it? No way. Oh, just a backslash n. Dang it. All right, good job, John. Good catch. Woo! We did it. We completed this one. Let's go. Nice. All right, let's submit this one. Kind of a brutal kind of a brutal ask if you ask me to have a beginner try to understand um a two-dimensional matrix, right? Did we talk about two-dimensional matrices in the arrays lecture in week 2? Because this is a brutal ask if you ask me. If you're trying to get a beginner to understand a two-dimensional matrix with a very surface level understanding of arrays, that is a brutal ask. Yeah, so Ryan, this is what I'm exactly as I'm saying is if you're struggling with the tabulate function that we wrote for the two-dimensional arrays, this please don't feel bad. In my opinion, that is a really tough ask to ask a beginner programmer on week 3 or whatever this is to understand two-dimensional arrays when I don't even think it was brought up in the week 2 arrays lecture. See that this is what I'm talking about with CS50 with CS50P as well, is that there's gaps that are left in these courses. And you have to get like a good beginner, like almost kind of like kiddie level, like not super kid, but just like super dumbed down to fill in those gaps. And if you're able to get something like with Python Crash Course, this filled in those gaps of CS50P that were like kind of like what we're seeing now is these lectures sometimes like will it doesn't talk about everything you need to know. And yeah, you need to be a good student and go through some third party resources and stuff. But in my opinion, if you're conglomerating a course as an entirety in itself, everything that should be applicable in the problem set should be talked about in the course. Now, I didn't watch like the shorts and stuff, so maybe they were talked about in there, but it just in the main lecture, um, yeah, this would trip people up for sure. Okay, Ryan wants us to go through our tabulate function. Okay, so right, the tabulate function, in order to understand the tabulate function, you need to know what's going on behind the hood in this bool vote function. So what we're doing is if we get a candidate, right? If we submit a vote, we have a rank, which is the rank or whatever in order that they gave the candidate in preference. The rank determines preference. It's not order of magnitude. So don't remove like the order of magnitude from this type of voting system. It's not based on magnitude, giving like each rank a value and then summing up values and having lower ranks getting lower values or higher values and vice versa and taking the inverse or whatnot. So it's not like that. It's the rank pertains to if the candidate is no longer available, well, the next rank is the next preference candidate I would like to do, or the next index, right? So what we did here is that with the bool vote function is once once you confirm that that candidate's name is a valid candidate, you access that two-dimensional matrix of preferences per that voter, right, in the X column, and the rank in the Y column. You set the actual index of the candidate count equal to that, like you had talked about earlier. We talked about this earlier, right? So if we have a two-dimensional array called preferences, right, it's going to look something like this, right? You have some two-dimensional array where you have rows and columns, right? And then you have voter 1, voter 2, voter 3, voter 4, etc., right? You have candidate 1, candidate 2, candidate 3, etc., right? Their ranking system would go here, right? The candidate 1, this would have a length of, let's say, 5. So you have a total of 0 through 4 ranking options for the total number of candidates. So that means that values of 0 through 4 can go into these squares. So let's say voter 1, candidate 1 was their top preference. Voter 1, candidate 2 was their third preference. Candidate, or their fourth preference because it's 0 index. Candidate 3 was their fourth. This would have been their second, and this would have been their third, right? Just like that. So now what we did was in the tabulate function here, right, is we iterate, we do a nested for loop for every, for every voter, right, in the vote count, and for every candidate in the the candidate count. We can now access their cross relations here with indexes I and j. So that's the whole point of creating this nested for loop, is now we can access these crossover or points within this matrix where these two indexes will meet. And at that point houses the index of the candidate at which they're, for that preferred rank preference. So what happens is we will say, okay, we're going to iterate over all the voter counts and all the candidate counts together to access, that assignment of the voting. If the candidate's preferences, right? So I said I kind of conglomerated a lot of these variables into just like single lines here. So what I said, so I access the candidate, the preferences in index I and j for that specific iteration. So let's say that we're on voter 1. Oh, we're on voter 1, right? We're on voter 1 for a candidate count 1, or 0 and 0 rather, right? So it'd be 0 and 0 rather. But we'll just go back for that. So we're accessing this square right here first. We're saying, okay, is this candidate eliminated? Okay, no, they're not eliminated. It's true, meaning that it's false, meaning that they're still in play. Well, is there a vote here? Right? Is there a value in this place? If it is, go ahead and say yes, there is a value there, and then pretty much tally the vote for that candidate. So you're just trying to search through these squares and identify if that candidate at this point, right, is valid. So if candidate 2 is eliminated, all of the squares in candidate 2 will be gone. So if we traverse through in our iteration up to this square and we determine, oh, this square is no longer available, right, we're not going to increase the vote count because there is no rank preference there, and so we'll just break out from there. But if there is a value here, let's say that we're searching on this one and it has a rank preference of 2 in here, well, we don't care really what the rank preference is here. We just care that there is a vote here for this candidate. And so then we go ahead and just increase the vote on that candidate by 1, right? We access the votes. Remember, this preference is all it does is access the index value associated with that candidate of 2 or whatever, up through the candidates list of 0 through 4 in this case, this specific example. And then we increase the vote count by 1 and we break from there. So it seems a little bit complex just because I'm kind of grouping these operations together by not candidate at this preference. I could specify specific variables to house these, but I'm just inserting them directly into them to save space. But right, so it's just basically looking for the point at which the candidate and the vote crosses over. Is there a preference for that point? Is it even available? Yes. If it is, okay, that is a valid vote for that candidate, for that voter. We'll go ahead and tally it. So you're just trying to, at each point after we eliminate a candidate, see if there's what the remaining votes are, and then go from there. Does that make sense, Trash Ketchum? Now, I probably did a bad job of explaining this just because I myself am still getting familiar with two-dimensional arrays, but this was how I was able to break it down. It did take me, a good hour to kind of figure it out, but I was able to get it here. Does that make sense? Right, because if you go back to our example here of the two-dimensional matrix, each voter is going to have a count here. So let's just say they counted in order. This was their first preference, this was their second preference, third preference, fourth preference, and fifth preference. Well, let's say that this counter was in the opposite order: 5, 4, 3, 2, 1. Um, hold on. 3, 4. This would be 4, 3, 2, 1, 0. Let's say that this one was random at 3, 1, 0, 2, 4. Let's say this one was random at 5, or at 4, 1, 0, 3, 2, right? So what we're doing is we're traversing after we eliminate a candidate. We are going to recount the votes at that point and see if one of them has majority. Awesome. Hopefully that helped you, Ryan. This one was a tough one, though. Definitely, definitely a mind bend for beginners, for sure. The two-dimensional matrix or a two-dimensional array is a tough ask, in my opinion, for a week 3 assignment. Especially if we didn't even talk about it in the lecture. All right, you guys, cool. Sweet, so we solved that one. Now, do we try to go on and solve the Tideman? Oh my gosh. Um, so Tideman says this one is really long. Oh my goodness. So you already know about plurality elections, which is follow a very similar algorithm for determining the winner of an election. Every voter gets one vote, and the candidate with the most votes wins. But the plurality vote does have some disadvantages. What happens, for instances, in an election with 3 candidates and the ballots are all cast? Alice, Alice, Bob, Bob, Charlie. The plurality vote would declare a tie between Alice and Bob since each has 2 votes. But is that the right outcome? There's another voting system called as a ranked choice voting system. In a ranked choice system, voters can vote for more than one candidate. Instead of just voting for their top choice, they can rank the candidates in order of preference. The resulting ballots might therefore look like the below. Here, each voter, in addition to specifying their first preference candidate, has also indicated their second and third choices. And now, what was previously a tied election could now have a winner. The race was originally tied between Alice and Bob, but the voter who chose Charlie prefaced Alice over Bob, so Alice could be declared the winner. Ranked choice voting can also yet solve another problem or drawback for plurality voting. Take a look at the following ballots of Alice, Alice, Bob, 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 Charlie, 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 Charlie. Who should win this election? In a plurality vote, where each voter chooses the first preference only, Charlie wins this election per the 4 bottom ballots. Right. Note that if you're familiar with instant runoff system, Charlie. Okay. Note that if you're familiar with the instant runoff system, voting system, Charlie wins here under the system as well. However, Alice might make a reasonable argument that she should be the winner of the election instead of Charlie. After all, of the 9 voters, a majority, 5 of them, preferred Alice over Charlie, so most people would be happier with Alice as the winner over Charlie, right? Because you have Alice as the first spot, second spot, second spot, second spot, for an in total of like an amortized kind of 2 out of 5, you know, where Charlie has the first spot out of 4, but Charlie's the third pick for the third one here, these guys. Who should win this election? Alice, however, might reasonably make the argument that she should be the winner of the election instead of Charlie. After all, of the 9 voters, a majority, 5 of them, preferred Alice over Charlie, so most people would be happier with Alice as the winner instead of Charlie. Alice is, in this election, the so-called Condorcet winner of the election, the person who would have won any head-to-head matchup against another candidate. If the election had been just Alice and Bob, or just Alice and Charlie, Alice would have won. The Tideman voting method, also known as ranked pairs, is a ranked choice voting method that's guaranteed to produce the Condorcet winner of the election if one exists. In a file called tideman.c, in a folder called Tideman, Create a program to simulate the election by the Tideman voting method. Okay, so we'll download the distribution code here. Oh, we need to go, yes. So let's go, hey Prashant, how's it going? Welcome back. How you doing? Okay, so let's take this guy. Let's take this guy. Take this guy. Yes. And then let's CD into Tideman. Okay. Okay, background. Generally speaking, the Tideman method works by constructing a graph of candidates where an arrow edge from candidate A indicates from candidate A to candidate B indicates that candidate A wins against candidate B in a head-to-head matchup. The graph for the above election then would look something like the below. Alice points to Bob, where Alice then points to Charlie, and Charlie also points to Bob. So, okay. The arrow from Alice to Bob means that more voters prefer Alice to Bob. The arrow from Alice to Bob means that more voters prefer Alice to Bob. 5 prefer Alice, 4 prefer Bob. Likewise, the other arrows mean that more voters prefer Alice to Charlie, and more voters prefer Charlie to Bob. So whoever points to has the least preference. Looking at this graph, the Tideman method says the winner of the election should be the source of the graph and the candidate that has no arrow pointed to them. In this case, the source is Alice, and Alice is the only one that has no arrow pointing to her, which means that nobody is preferred head-to-head over Alice. Thus, Alice is declared the winner of the election. It is possible, however, that when the arrows are drawn, there is no Condorcet winner. Consider the below ballots, where you have Alice has 3 winning ranks, Bob has 2, Charlie has 4. Bob comes in second twice, Charlie comes in second twice, Bob comes in 3 times, Charlie twice, Alice 4 times. Between Alice and Bob, Alice was preferred over Bob by a 7-2 margin. So Alice is preferred over Bob how many times? Alice is preferred over Bob here, 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 and here, but not here and here. Gotcha. 7-2. 1, 2, 3, 4, 5, 6, 7-2. Perfect. Bob is preferred over Charlie by a 5-4 margin, but between Charlie and Alice, Charlie is preferred over Alice by a 6-3 margin. If we draw out the graph, there is no source. We have a cycle of candidates where Alice beats Bob, who beats Charlie, who beats Alice, much like a game of rock, paper, scissors. In this case, it looks like there's no way to pick a winner. To handle this, the Tideman algorithm must be careful to avoid creating cycles in the candidate graph. How does it do this? The algorithm locks the strongest edges first, since those are arguably the most significant. In particular, the Tideman algorithm specifies that matchup edges should be locked in to the graph one at a time based on the strength of the victory. The more people who prefer a candidate over their opponent, the stronger the victory. So long as the edge can be locked into the graph without creating a cycle, the edge is added, otherwise the edge is ignored. How would this work in the case of the votes above? Well, the biggest margin of victory for a pair is Alice beating Bob, since 7 voters prefer Alice over Bob. No other head-to-head matchup has a winner preferred more than 7 votes. So Alice-Bob arrow is locked into the graph first. The next biggest margin of victory is Charlie's 6-3 victory over Alice, so that arrow is locked in next. Up next is Bob's 5-4 victory over Charlie, but notice if we were to add an arrow from Bob to Charlie, now we would create a cycle. Since the graph can't allow cycles, we should skip this edge and not add it to the graph at all. If there were more arrows to consider, we would look to those next, but that was the last arrow, so the graph is complete. This is a step-by-step process. This step-by-step process is shown below with the final graph at the right. So you just have a no edge on Charlie and Bob. Based on the resulting graph, Charlie is the source. There's no pointing arrow towards Charlie, so Charlie is declared the winner of this election. Put more formally, the Tideman voting method consists of 3 parts. Tally, once all of the voters have indicated all of their preference, determine for each pair of candidates who the preferred candidate is and by what margin they are preferred. Sort, sort the pairs of candidates in decreasing order of strength of victory, where strength of victory is defined by the number of voters who prefer the preferred candidate, and lock. Starting with the strongest pair, go through the pairs of candidates in order and lock each pair to the candidate graph, so long as locking in that pair does not create a cycle in the graph. Once the graph is complete, the source of the candidate is the one whose edges point towards it. It's the winner. Understanding. Let's take a look at Tideman C. Okay. First, notice the two-dimensional array preferences. The integer preferences I and j will represent the number of voters who prefer candidate I over candidate j. Will be, okay, so the two-dimensional array preferences is the integer at the location of preferences I and j will represent the number of voters who prefer candidate I over j. The file who defines another two-dimensional array called locked. The file also defines another two-dimensional array called locked, which represents the candidate graph. Locked is a Boolean array, so locked I and j being true represents the existence of an edge pointing from candidate I to candidate j. False means there is no edge. If curious, this representation of a graph is known as an adjacency matrix. Next up is a structure called a pair, used to represent a pair of candidates. Each pair includes the winner's candidate index and the loser's candidate index. The candidates themselves are stored in array candidates, in which an array of strings represent string S representing the names of each of the candidates. There's also an array of pairs, which represents all the pairs of candidates, for which one is preferred over the other in the election. The program also has 2 global variables, pair count and candidate count, representing the numbers of pairs and the number of candidates in the array pairs and candidates respectively. Pair count. Yeah, this one is tricky, huh, John? Now onto main. Right? Notice that after determining the number of candidates, the program loops through the locked graph and initially sets all the values to false, which means our initial graph will have no edges in it. Next, the program loops over all of the voters and collects their preferences in an array called ranks via a call to vote, where ranks at index I is the index of the candidate whose ith preference for the voter. These ranks are passed to the record preference function, whose job is to take those ranks and update the global preferences variable. Once all of the voters are in, the pairs of candidates are added to the pairs array via a call to the added pairs, sorted via a call to sorted pairs, and locked onto a graph via a graph called locked pairs. Finally, print winners called. Further down the file, you see functions vote, record preference, add pairs, sort pairs, lock pairs, and print winners left blank. That's up to you. Okay. Here we go. Specification. Complete the implementation of Tideman C in such a way it simulates a Tideman election. Complete the vote function. Okay. Vote function here. The function takes arguments rank, name, and ranks. If name is a match for the name of a valid candidate, then you should update the ranks array to indicate that the voter has the candidate as their rank preference, where 0 is the first preference, 1 is the second preference, etc. Recall that ranks at index I represents the user's ith preference. The function should return true if the rank was successfully recorded, and the false otherwise if, for instance, name is not part of the candidates. You may assume no two candidates have the same name. Okay, I need to turn on my heated blanket here. It's getting a little cold. Oop, let's get that on. Okay, let me be right back. I'm gonna grab some lemonade. Lemonade. Okay, we're back. We're back and we're better. How you guys doing out there? For those of you guys that are new here, thanks so much for joining me. My name is Michael. I've been streaming every day for the past about 2 months or so. I graduated from college back in 2021 with a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company right now where I make biological controls. And I've just been teaching myself Python and now C for the past 6 or so months, just trying to gain additional skills and improve as a general in my general education, right? So thank you so much for joining me. Right now we're doing Harvard CS50X. We're on week 3 in algorithms. We've been doing this since the beginning of the year, so we're making quite good progress. So yeah, if you guys are interested in following me to the end of this course and doing it alongside me, feel free to join me and join the Discord link below. Okay. Whew. Okay, the function takes arguments rank, name, and ranks. If name is a match, so I'm going to go back to my runoff function. I'm going to copy over here. I'm going to copy over here my candidate count, circomp name. So Tideman has preferences, candidates, a candidate count. Okay. So then I'll take pretty much this entire thing here. I'm going to bring it into my Tideman here. Paste it here. Okay, so we'll say for I equals 0 to the candidate count, we're going to compare the string of the name. If that goes through, then what are we going to do? Then you should update the ranks array to indicate that the voter has the candidate as their rank preference. So ranks at index I is equal to I at this case. So we would say that the rank preference represents the user's ith preference. So as I increases all the way through the candidate counts, the available candidates, the count of candidates, or the length of candidates, then the rank 0, ranks at index 0 will equal If name is a match for a valid candidate, if the name is match for a valid candidate, then you should update the ranks array to indicate that the voter has the candidate as their rank preference. So that the update the ranks at that index ranks. If the name is a match for the candidate of a value, then you should update the ranks array to indicate that the voter has a candidate as their rank preference. No, candidate at index I is equal to rank. As their rank preference, where 0 is a rank preference for the first, 1 is the second preference. Okay? I think that that's it. Or it could be ranks, rank I. Well, this is going to save in the 0 place the rank of that Okay, so hold on. No, it's going to be rank at index I think, like that. We're going to update the rank position at the index I. So if you go to the 10th rank, well, that'll be the ith candidate. Yeah, so you go to the 11th rank, that'll be the ith candidate. I think that's how it's supposed to go. Complete the record preferences function right here. The function is called once for each voter and takes the argument of ranks. The function is called once for each voter and takes an argument ranks array, which recall that ranks at index I is the voter's ith preference. Where ranks index 0 is the first preference. The function should update the global preferences array to add the current voter's preferences. Recall that preferences I and J should represent the number of voters who prefer candidate I over J. Okay, so record preferences. The function is called once for each voter. And takes the argument ranks array. The function should update the global preferences array to add the current voter's preferences. So the global preferences array is here. Record preferences. The function should update the global preferences array to add the current voter's preferences. So where is this called at in here? So record preferences here on ranks. The function should update the global preferences array to add the current voter's preferences. So given the ranks, ranks at index 0 is the first preference. Okay, so hold on. Think about this. So the function is called once for each voter. Right, okay, so we say for int I equals 0, vote count, voter count is greater than I plus plus. Okay, so we're going to iterate over every voter count and takes the argument as arguments a ranks array. Candidates I.name ain't a thing no more. Okay, let's see here. What's our structure for a pair? So bool gives us vote. Pair is our structure with winner and loser. Preferences locked. Array of candidates. Get string name. So we don't have a candidate anymore? So how can we compare the name of a valid candidate? Candidates is here. Which is just a array of names, array of candidates. Okay, so we just have an array of candidates, which are their names, I'm guessing. So candidate count, candidates, index I, which will house the name of a candidate, anything like that. So we won't access the name of a candidate, just the actual candidate, which is the name itself. Right? So our goal here now is to iterate over the vote count. Okay, let's try to move on to the add pairs for right now. Add pairs The function should add all pairs of candidates where one candidate is preferred to the pairs array. A pair of candidates who are tied, one is not preferred over the other, should not be added to the array. The function should update the global variable pair count to be the number of pair of candidates. The pairs should thus all be stored between pairs 0 and pairs index pair count -1 inclusive. Oh boy. Add pairs. The function should add all pairs of candidates where one candidate is preferred to the pairs array. So what is the pairs array? Pairs array is here. Max 9 times 8 divided by 2. You said voter count is scoped to main. You have voter count here. Yeah. Okay. So then voter count wouldn't work in here either. This one's definitely trickier. Add record preferences. So the function is called once for each voter. It takes an argument of ranks. The voter's ith preference the function should update the global preferences array to add the current voter's preferences. What does that even mean? So preferences is just 9 by 9. Preferences, the number of voters who prefer I over J. 10 voters prefer candidate 0 over candidate 1, or over 0, 2. Sit up here, we gotta focus. The function is called once for each voter. Call it here. Core preferences on rank. Okay, yeah, so it's called once for each voter inside of this count. So we don't need to do the looping. So you do it on the individual scope of each voter. So you just record the preferences of that voter's ranks. Okay. So then the ranks, what does it do? So we'll say ranks anyone have any ideas? So we need update preferences. Preferences so if it takes in ranks, so let's say for int I equals 0, something less than I plus plus. Right, so what is going to be less than I here? What's a global variable that we can use? Candidates, pair count, candidate count. Going over the entire candidate count. So we're going to iterate over the entire list of the candidate counts. Because we're going to update the preferences for every voter. For I, the candidate count. And then for J, I is the we already are doing a loop over voter count, candidate count. Okay. The function should update the global preferences variable. So we need to get access to the I and the J. So the ranks, though, has the candidate count index. So okay, come on. Think, Mike, think. So we are we definitely are trying to get access to the preferences or matrix. So we need an I and we need a J. But what are we pulling that from? From the ranks. So ranks is going to house at each index, according to this, ranks is going to be updated upon each iteration, the rank of that value. So we're going to save the rank as that index. So on index 0 is going to be the rank. So for the first candidate, the rank is going to be associated with that index value in ranks. Ranks index I equals rank. So we're going to access the ranks for that specific candidate index. We're going to equal it to the rank that we're currently applying. So if there's 50 candidates, it's going to have 0 through 49, and it's going to assign the rank. Let's say they were on candidate 0. It's going to assign, let's say that they have a rank 10. It's going to assign 10 to that 0 index of ranks. So candidate count, 0 through candidate count. We're going to access the ranks array at index I, which is equal to the rank of that candidate. Tideman. Not Tideman. Tideman. So if we save at each candidate count the rank associated with each candidate, we need to record preferences given the ranks updates the preferences array so we need the current voter, which will be I, ranks oh, come on. Come on. Think. For I, the candidate count, for J, in the, they use J for the candidate count and they use I for the voter count here. I need to get access. So we're trying to save the specific voter's preferences. So their preference is the current voter's preferences. Recall that preferences index I and index J should represent the number of voters who prefer candidate I over candidate J. I don't know. The sort pairs function. The function should sort the pairs array in decreasing order of strength of victory, where strength of victory is defined by the number of voters who prefer the preferred candidate. If multiple pairs, oh boy. kind of want to move on and try this a different day. Come on. Think. You can do this. So, bool vote. Given a rank and a name, ranks at index I is equal to rank provided. True. So if it's the 0 candidate, then they have a rank of 10. The 0 base 10 was saved. Then what do we do at that ranks for the specific candidate? We take the rank. We take the rank at index I. The ranks is proportional to candidate count. So you would use candidate count here to record preferences. Right, and so if you use candidate count to record preferences, then right, ranks at index I is proportional to the candidate count. So we go ranks at index I, that accesses the rank of each candidate for this specific voter. So then we need to update the preferences. Should update the array to add the current voter's preferences so that yeah, I'm not sure. Kind of getting over this for today, though. What do you guys think? Anybody have any thoughts? Chat's pretty quiet right now. People might be stumped here. Yeah, I'm not really sure. This is really jargony. I might need to come back on this on another day. Um, Okay. Well, oh, anybody have any ideas? Design 50. Hmm. Hmm. Okay, come on, let's think. Stop getting distracted. So complete the record preferences function. If the name is a match, then you should take the ranks. Okay, so I think that this is right. Now this one. The function is called once for each voter and takes an argument of the ranks array. Recall that the ranks at the index I is the voter's ith preference, where ranks 0 is the first preference. The function should update the global preferences array to add the current voter's preferences. Recall that oh, okay, so we have preferences here. So we just need to update the preferences array with the preferences of the ranks. So candidate I over J. So we need to say for I over the candidate count and for J equals 0 over the candidate count. Now we iterate over the candidate count, ranks at index I 0. See ya, Trash Ketchum. Appreciate you coming in tonight. Have a good night. Have a good Saturday. I'll see you tomorrow. Good job on the runoff. So preferences I and J should represent the number of voters who prefer candidate I over J. So we just need to go over to that spot in that matrix and update it by 1 if this voter prefers I over J. So for every candidate, for every rank, right, we're going to access every ranks, all the ranks. Which means so if rank 0 would be like 21, that would access the candidate count. Candidates at this index would access the candidate proportional to that index. So if the first value 0 is rank 25, or like rank 5, the candidates will access the 5th index in candidates. Rank 0. If I is 0 here, that value is 25, and this is 25th value. And then we need to save that value. If this value, if the rank is lower than that, but what about J? I'm in problems with J. So if you have a matrix, you have right? You have candidate 1, candidate 1, 2, candidate 2. Ah, come on. My brain is hurting. Come on. I'm losing it. I'm losing my edge here. Come on. So if we're evaluating a matrix of candidates, oh my gosh, come on. The function is called once for every voter and takes the ranks of that voter. Recall that ranks at index I is a voter's ith preference, where the ranks 0 is a voter's first preference. So ranks at index 0 would give you the proportionate candidate I'll give you 0, 25. So candidates at value of like 2, 0 would give you let's say ranks at index 0 is 0. So that would give you the first candidate the function should update the global preferences array to add the current voter's preferences. Recall that preferences index I, J should represent the number of voters who prefer candidate I over candidate J. So what can we do to access J? I'm not sure. Anybody have any thoughts? Anybody have any ideas? I'm not sure how to get to this J, what to do with this J. So we're saving the ith rank, the ith nested for loops. But what are we looping over? Right, what are we looping over? So in I, we're looping over the candidate count. So if you have 10 candidates, 0 to 9, will access you 0 through 9 candidates. To provide you the rank of that candidate. Yeah, I'm slowing down here. I might need to try this one tomorrow. All right, I'm gonna try this one tomorrow. I think I'm just gonna be done for this one today. It's not really going anywhere here. All right, you guys. Thank you so much for joining me today. We streamed for just over 3 hours, almost 3 hours and 10 minutes today. We completed the runoff problem in week 3 algorithms of CS50X. We are currently working on Tideman, which is the second optional problem. It's not required to complete this week, but I do want to complete it, and it is pretty difficult here. I'm having some struggles, so we'll have to come back to this one tomorrow. But I might come back a little later tonight for some late night coding, maybe about an hour and a half. So be on the lookout for that. I'm just going to take a break here, grab some dinner, and just chill out here, take my dog out. But I might come back and do some just late night coding on my small business manager, just really chill into the evening. So thank you so much for joining me today, guys. Take a look at the Tideman problem and then try it out for yourself. I'm currently on the record preferences function. I was able to do the vote function, but I'm having problems with getting the record preferences function and knowing how to update that preferences matrix. So try this one, and then we'll come back and meet up tomorrow and go over it again and see if we can try to solve this one. But I'll be in the Discord tonight, so if you want to interact with me, I'll probably either jump in there and just hang out in the call, or just be like in there just hanging out in chat. So chat with me in the Discord link below. You can get access to like Python Crash Course, all of my books that I'm reading on live, all of my problem sets. You can get access to my Harvard CS50X information on there as well, and my problems and my answers. And as well as I posted today the condensed version for week 2. I uploaded that one, part 1. I'll upload the part 2 probably on tomorrow or Monday. And then I'll shortly chop up the week 3 on algorithms that we just watched this past week. So thank you so much for joining me tonight, you guys. It was a little bit of a shorter one for a Saturday, but we're just grinding through some of these problems, and it does take a lot of my brain power away. And so, like I said, I might come back a little bit later in about an hour and a half, 2 hours for maybe some just live coding, just into the night. But yeah, we'll go ahead and give this one another shot tomorrow. So thanks so much for joining me tonight, you guys. I'll be back tomorrow and on the Discord. I'll see you guys later. Thanks so much for subscribing and follow along. See you guys.